Okay, we're live. So, for you to actually appreciate and enjoy what you're doing, you have to always have the picture of P1 in your head, okay? You want to master P1? Fine. Then have the picture in your head. So, remember that P1 has 8 things for you to know. 8 things for you to know. You must know these 8 things for you to say you're good at P1, okay? You should know quadratics, you should know quadratics, you should know functions, you should know blah, 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 blah. Okay? Can you see all of them? Yves, can you see the screen? Yeah, I can hear you. Okay, good. So everything that we do comes from here. The things that I was explaining when I was explaining, she, I had been asked to explain. Please explain series to me. Okay, that was the question. So in the last video, I started from there, and we ended up doing trigonometry and we did stuff. But when you're doing series, what I wanted to understand is that this is a two-in-one chapter. When you do series, you do the binomial theorem, and then you do something which stands alone, which is not part of the binomial theorem, and this is AP and GP. Are we together? So it's like when you're doing series, you should ask yourself, Yves, can you hear me? Okay. You should ask yourself, am I doing binomial theorem or am I doing AP and GP? Okay? Hi, Remember, how are you? Remember, good evening. Is the network glitch my side? Can you hear me nicely? Okay. I'm checking if you can hear me nicely. So I'm going to do pure maths P1 for like 20 minutes. I'm going to do P1 for like 20 minutes and then we do statistics, okay? Yves is from Saints and they're writing P1 on Friday. So I just want to kickstart him and then we get to do our statistics. Okay, Yves? Rainbow? Okay. Okay. So what I was saying, I'm going to show. Yves, when you go to the other video, you're going to see that I started by explaining binomial theorem, and and then the difference between this one and AP and GP, and we did several questions to make sure we're good at them. We're doing past paper questions, so when you do it, you'll be fine, and you see how to use MF19 for that. Then we also did trig. Okay, Yves. So it's like you needed to know. First of all, you should know that when you are doing series, do not mix up binomial theorem with AP and GP. They are different things. Binomial theorem is its own thing. It's about expanding. It's all about expanding. So they'll give you something, can you expand this and stuff like that. AP and GP is now about finding a hidden term. We have a sequence and we want to find a hidden term. Or we want to find the sum of terms that we don't know. So we use this. Right, good. Then comes integration and differentiation. Right. So if I can go to a paper one, I want to do differentiation and integration questions and show you something. Let me go to it. So this is um this is February, March last year. And we come to this number 9 and we're doing this differentiation. So let me quickly explain so you don't waste time. Paper 1 differentiation is so easy, even integration. Okay, so let me explain to you what it's like. It's so easy. This is paper one, so I'm going to narrow it down. I'll give you the whole explanation that I was giving Rovimbo and her team, but I'll only give you when we are now doing paper three, not now. So now I'm just going to simplify it for paper one. So differentiation works like this. You only have to know one thing, sir. You have to know, the first thing is, you just have to know what we call the power rule. This is the only thing you got to know first. You have to know the power rule, which says that you have to know what we call the power rule. Power rule says if y is equal to ax to the power of n, then dy dx is equal to an x to the power n minus 1. This simply means if you are differentiating anything with x and a power, if you are differentiating anything with x and a power, you drop the power, and reduce it by 1. Okay, so here let me say, drop the power to multiply. You drop the power so that it multiplies, and you reduce the power by 1. You reduce the power by 1. So you drop the power so that it now multiplies. Look here, we had n as the power. We drop it. Look here, it's now an. This is now an. It's now multiplying. Then we reduce that power by 1. You already know that. Then you have to know the second thing, which we call the chain rule. So wait, let me just do an example. So example, e.g., is if y is equal to x to the power 3 minus 4x squared plus 9x minus 7. Okay? Then dy dx will be drop the power, reduce it by 1. So this is polynomials. We drop 3, it becomes 3x squared. We reduce it by 1. Minus, we drop 2, it multiplies 4, it becomes 8. We reduce it by 1, it becomes 8x. Plus, you differentiate this one. You drop 1, it becomes 1 times 9, 9. You reduce it by 1, x to the 0, so it just becomes 9. And you are done, because there's no power to drop here, so it's gone. This is going to be the derivative. This is your power rule. Then it goes to the second rule, which is now the chain rule of differentiation. Chain rule says to differentiate a composite, function, one, differentiate the outside. You start with the outside, okay? You differentiate the outside. In brackets, I want you to say, without changing the inside. Without changing the inside. Then to multiply by derivative of the inside. Differentiate the outside. Then multiply by derivative of inside. You can put it in caps. Inside. So, e.g., if you now get something like this, because we are dealing with a composite function, which means function in a function. We're dealing with a composite function, which means function in a function. So this is the nice situations you'll be getting. Y is equal to x squared minus 5x all to the power of 7. How do you differentiate this one? So, we know the power rule, and chain rule said, start with the outside. Chain rule said, start with the outside. So, you must know that this is the outside, and this is the inside. So, if you want to get your dy dx, you start with the outside. Don't touch the inside. Start with the outside. Let's differentiate the outside. What is it? 7. How do we differentiate it? You drop the power and reduce it by 1. Don't forget, you drop the power so that it multiplies, you reduce it by 1. So we drop the power to go in front, so it becomes 7. And don't change the inside. Here it says, don't change the inside. In the first step, don't change. So the inside is still x squared minus 5x. It's not touched. We just dropped the power outside, and we reduce that power by 1. It becomes power 6. Then we multiply by the derivative of the inside. The derivative of the inside was the derivative of x squared. We drop the power 2, reduce it by 1, becomes 2x. Minus the derivative of 5x is just 5. So we now have multiplied by the derivative of the inside. So your final solution will be like this. 7 multiplying 2x minus 5 multiplying x squared minus 5x to the power of 6. This would have been your final solution for this one. Yves, have you seen how to do the chain rule? Yves? The biggest thing that I need you to do so that we move is always, when you get a rule, I want you to throw away anything you'll be having. Put the rule. Yes, I can hear you. I can hear you. Put the rule, and then stick with it. Okay, Yves? Don't ever stop. Stick with the rule. You have to stick with the rule. Remember? The outside without touching the inside. Then you multiply by derivative of the inside. Now, this is done. So if you know this, you're good. You're good for AS. Let me give you a second example. And let me show you where now, let me show you what they now will do. Here's another example of x cubed minus 5x. Something like this. They want you to differentiate. So you must know that before you differentiate this, we never differentiate anything with a square root. There is no such thing. There is no day that you can do it. You should change it first before you start differentiating. So change it. You say y. You haven't said dy dx. No. It's still y. You change its form. It is x cubed minus 5x. This is to the power half. Square root means power half. Then now you can do your chain rule. Dy dx, you start with the outside, then you end with the inside. How do you do the outside? A lot of people will say, oh, how do I do the outside? How do I differentiate the outside? Just drop the power. Drop it so it becomes half. Don't change the inside for now. Then reduce the power by 1. It becomes to the negative half. Then multiply by derivative of the inside. Derivative of x cubed, it drops. It becomes x to the 2. Minus derivative of 5x is just 5. So it's like this. So what you end up having is half multiplying 3x squared minus 5 multiplying x cubed minus 5x to the negative half. Then, since this has a power, you can now simplify it and stuff. But I don't want to waste time right now. I'll explain those stages later. Right, so this is how you do it. Now, where you now need to make sure you don't let me down is application. AS is all about application. So why is differentiation hard for AS? If it's only these two, the power rule, which we have mastered, and the chain rule. Why is differentiation hard? Because there is application. You must know how to find stationary points. After differentiating, though, first you differentiate using what we have studied already. So you differentiate using what we have done, but then you should now know how to then use the derivative to find stationary points, number one. Number two, to find equation of tangent. Number two, to find equation, number three, of normal. Number three, to find nature of stationary points or turning points. Or they can say find the maximum point or the minimum point or whatever. Nature of stationary points. You must be able to find these. And finally, you must be able to find rate of change. These are the things that they will ask you. But for you to find them, the first thing you find is the derivative. Then we will now train you how to use the derivative to find them. So let's go to a past exam question, and you see, they will ask you to find one of these things. Look at this. Here. This is integration. Right. Okay, so this is again integration in here. Here, let me see if they put differentiation as one of the first questions. Look at this here. Find gradient of curve. So this is an application. I want you to go in an exam knowing that they only ask for application. They expect you to know how to differentiate. Then they expect you to then know how to use your answer. So they will never ask you, what is the derivative? That's a textbook question. In a past paper, they will ask you, please find for me, what did I say? Gradients. These are now applications. What we use the answer to find. We can find gradient. If we know dy dx, we can find gradient. If we know dy dx, we can find stationary point. Don't let me down. We are going to use the dy dx to find these things. If we know dy dx, we can find the nature of the stationary points. If we know dy dx, we can find the, what is the other thing? If we know dy dx, we can find the equation of normal or tangent. Equation of tangent, I'll teach you. If you know dy dx, you can find equation of normal. If you know dy dx, you can find whatever, rate of change. But don't try to find them if you don't have dy dx. You are wasting our time. Because this is application. Find dy dx first. Come on now. If they ask for these things, the only way to get them is find dy dx. So I see, by the way, not just gradient. Gradient of a curve. If it's gradient of a line, you don't need it. Gradient of a curve. So they say here, find the gradient of a curve. Oh, okay. We have to find it. So it's application. First, we have to find dy dx. Before we think of all that, we have to find dy dx for this. So we must differentiate this. Now, listen to the rules. You don't differentiate anything that has a fraction or anything that has a square root. So basically, if you have a fraction like this, you must be able to change it. So you change your y. It will be 2x squared minus, when you remove x from the denominator, his power becomes negative. So whatever his power was, it will become negative. Here it was power 1. So it will become negative. So it will be 5x to the negative 1. Then you say plus 3. Now you have something you can actually differentiate. Why are you differentiating? Because they want gradient. Gradient is an application, gradient of the curve. You need derivative so that you find it. So now let's do the derivative. We say dy dx is equal to, let's differentiate. Don't let me down here. Drop the power, reduce it by 1. 2 by 2, so this 2 drops here. 2 by 2, 4. You reduce it by 1, it's now x to the 1 instead of x squared. Then this minus 1 will come and multiply this minus. It becomes a plus. It becomes a plus 5. Then it's now x to the, you reduce the power by 1. It becomes negative 2. Then derivative of a number is nothing, which you can simplify to say dy dx is equal to 4x plus 5 over x squared. We put it back in the denominator and its power will become positive again. Oh, well done. Now, what you have to do is find gradient. Now, we are starting application now. So, we have dy dx. Now, let's see how to find gradient. Then, later we'll see, after finding dy dx, how can I find other things? Here we are finding gradient. So, to find gradient, you just go to the point where they tell you. They tell you you are at point P. So you go to point P, you see it has x being 1, y being 0. So you're going to just say, let x be 1. Because that is the value at point P. If x is 1, that means now your dy dx, this one, which you have found, will be 4 by, wherever there is x, we are now putting 1. So it becomes 4 by 1 plus 5 over 1 squared, which is 4 by 1, 4, plus 5 over 1 squared is just 1. So it's 4 plus 5, which is 9. So our gradient is 9. So I expect you to now know how to find gradient from your dy dx. What do? Yves, when you're finding gradient, you put in the point. Can you see this, Yves? At our point, our x was 1. So we let x be 1. Then you will find your dy dx. But this is only after finding your dy dx. Last thing. Now they want coordinates of m. This is a silly game. They always ask. Find coordinates of m. This is just a turning point. This is the turning point. Find the turning point. So, Yves, turning point is another application. Turning point is another application. So to find it, we need to use dy dx again. So it's good that we have it, because dy dx can find me gradient, can find me turning point or stationary point, can find me all these things. So I have it, so you have to start from there. dy dx is what? 4x plus 5 over x squared. Now we have it. We saw how we used it to find the gradient. Here we were using it to find gradient. Now, and we saw that you put in the value. If you want to find gradient, tell us where you are. What is your x position? It is 1. So put 1 where there is x and you have the gradient. Now for m, you let dy dx equal to 0. Because you are finding a stationary point. It's a stationary point. For stationary point, how do you do application? What do you do after finding dy dx? You let it be 0. Because at stationary point, there is no gradient. It's flat. It's the turning point. It's flat. So dy dx is 0. You let dy dx is 0. What is your dy dx? 4x plus 5 over x squared. This is equal to 0. 4x plus 5 over x squared. This is 0. So we just have to solve. Our job now is to solve. So let's say we take it to the other side. You'd have 4xb equal to negative 5 over x squared. Then you take x squared to the other side. You're going to have 4x cubed is equal to negative 5. Right? Now, because x, look at it, 4x is equal to here, which means 4x by x squared is equal to negative 5, because we'll take x squared to the other side to multiply. Then it becomes 4x cubed is equal to negative 5, which means x cubed is equal to negative 5 over 4, which means x will be the cube root of negative 5 over 4. Can you punch this? What do you get? What is the cube root of negative 5 over 4? What is the cube root of negative 5 over 4? Change it to be a fraction. Can you get it as a fraction? You can't. It's just negative 1.0. Okay. So negative 1.077 or something like that. Right. Now, they said find the coordinates. Yeah. Okay. They said find the coordinates of m. So they want them as coordinates. So what you're just left with is to know the y value. So you bring back this y. You say y is 2x squared minus 5 over x plus 3. So y is 2x squared minus 5 over x plus 3. Then you say let x be equal to negative 1.077. Because they want it as coordinates, which means you need x and y. So your y will be equal to 2 by negative 1.077 squared minus 5 over negative 1.077 plus 3. So if you can punch this nicely, then you can get your final solution. What is y? Punch this like this. Minus open bracket 5 over whatever close bracket. Then you say plus 3. What is the final solution for y? 9.96. So here you have your X, you have your Y, you are done. What is the main thing? If they're looking for stationary point, this is how you do the application. So as long as you are doing P1, remember, as long as you are doing P1, remember to focus on, as long as you are doing P1, remember to focus on application. Yes, finding the derivative is easy, but you must know, if you want to do well, focus on practicing how you use the derivative to find different things. Here for stationary point, you let dy dx be 0. For gradient, you put in your p. P was 1 for x, so you said let x be 1 in your dy dx. You don't make dy dx be 0. You don't make it 0 for gradient, but you make it 0 for stationary point. Now you need to know, what do you do with dy dx for equation of tangent, and what do you do with dy dx for equation of normal and all that stuff. But either way, this will be it for how to do the differentiation on this. So Yves, I'm going to have to prepare with Ruvembo for your exam tomorrow. I want you to watch the video we did yesterday where we talked about trig and we talked about that chapter of series. So the chapter of series and you may need a nap or something, and then you go for it. So the chapter of series, which is binomial theorem, then AP and GP. They are different. Then after that, you do trig, which is its own thing as well, We did some past paper questions yesterday. Then you can brush up, and we'll meet and continue tomorrow. Okay? I'll see, but I'll try to be even earlier, maybe, if I can, so that I can split you guys and get more time. So I'll squeeze it in with my other classes, and I'll tell you what time is perfect. Okay? Yeah, we'll stay in touch. Cheers, Yves. Goodbye, and